Now it should tell me, yes, we are recording. Okay, welcome to week 2. We have 2 people that have joined the class, and I've met with them in Zoom just one-on-one to go over the website. I'm not going to go over the website again, except for just a few little highlights of things that have changed. So the first is in your drop-down menu, we weren't sure at the start of first week whether homeworks would have a percentage grade or just a number of how many you completed by getting 8 or more. And the same with the quizzes. Do you care what score you get on a quiz, or just that you get at least a certain amount, like 2 out of the 3 problems right? And so we talked about that in class in an email and decided that the percentages were needless bookkeeping. So it tells you how many quizzes you've done, how many homeworks you've done, how many discussion forums you've done, how many achievements you've done, and none of those are percentages. They are just, did you do them well enough? Yes or no. The only thing you'll have a percent at is on the final. And to emphasize that, then I've put in percent symbols in this example for the final that weren't there before. That's the percent, everything else we're just counting. And again, these numbers go down except for the final percent based on your achievements. Yes, question.
Are we supposed to be seeing the screen? Because I just see
Oh,
you.
I forgot to share the screen. Okay, I am dopey. Let me try again. Thank you for interrupting. Okay, now you're seeing my screen. It's not glowing green. Let me try it again. There it goes. Now it's glowing green. Okay, now you're seeing my screen. Okay, ta-da. So when you're looking at your drop-down list, then these are all just numbers. How many quizzes, how many homeworks, how many discussion forums, how many achievements. The only thing that will have a percent would be the final. And in the chart, then I've put percents here to say, this is the percent. The others were just counting. And then as you heard, these paragraphs tell you about how the achievements make that easier, lowers the numbers you need. And somebody wanted a list of all the achievements. So that link is right here, and there's nothing here but all the achievements. If you were meeting with me in person, some people like actually putting physical sticky stars on the paper, and I would offer to print out the list of all the achievements and every day bring little sticky stars to class so you can mark them off if you wanted. But we don't have that. You have to go shopping and buy your own sticky stars because remote learning is terrible. Okay, so that's one change. I wanted to ask, nothing has changed here. When you click on this picture and you get the actual slide with all the links you can click on, has this been working for people? Has tutoring been good? Have they changed their times and didn't tell me? Any good or bad stories of trying to get tutoring last week?
So far, no issues. Everything's pretty smooth sailing there.
For me personally, I use the e-tutoring one, and that's the one that you can just drop in and they have times, whereas like scheduling a one-on-one tutoring session. You're muted.
I'm sorry, out of practice. Okay, the weekly to-do list should be more simple and easy. We agreed to have just one Get Help forum for the whole term. No need to make different ones. I am subscribed to this. So I went into the settings here and picked subscribe to the forum. So anytime you put a question here, I will get an email. If you want to subscribe also, you can. And then you will know when your classmates put a question here and maybe you could help them. But that is optional. We're not going to flood your inbox with everyone's questions. You don't have to do that. You could just email me a question, but it's a little more helpful to everyone else in the class if you use the forum, because then they can see the answer if they have the same question. The activity, we decided to make its own page. People wanted to be able to print it more nicely and work at a desk or a table, which makes sense to me. So rather than being an unfolding accordion, that's now its own page, easier to print. The only discussion forum that you are automatically subscribed to is the week 1, where you're introducing yourselves. So if I go to week 2, there's already a little bit of activity in the discussion forum, but you don't know that from emails. You are not going to get any more emails about the forums unless people continue talking about introducing themselves from week 1. Melanie had a note from Elaine, from Elaine's 105 classes. So there's a 2-page thing, and that is now right here. Whoever made up these finance formulas wrote them in like the most confusing way possible. So we will write them better when we get to them. But if you like this, if you have seen this before, then this is now right there. And that's
I
about
have
all
to
for
agree, David, about those. You know, I haven't, I looked at them and I thought to myself, you know, that's great if you know how it works already. You know what I mean? It's kind of like a cheat sheet, so to speak, if you already know which one to go with. So yeah, I know what you mean by that.
Mhm. I should also comment that if you want in study sessions, I will record things, but unless you ask me to, I won't. I'm assuming people there are not showing up to work on homework to be recorded forever. So we have the Jamboard from Saturday night, since we did a bunch of problems, but I didn't actually record anything. And that will just be how things are for study sessions. If we write enough to record the writing, I will keep it, but I don't normally make recordings. Okay, week 2 and 3 are safe to look at. Week 4 and on, I haven't finished organizing them. It's still a bunch of garbage using Paula's grading system instead of mine and so on. So don't go beyond week 3 if you want to look ahead. The exception is that I have put up my draft of what our practice final will look like. So let me click on that. It says at the top, be careful, everything might change. So heads up, everything might change. But how this will work once it gets finished is you'll have a bunch of problems. Here we go. And at the bottom, there'll be an answer key. And every time you reload it, the numbers change in the problems. So look at number 1, 8, 139, we reload it, and they're different numbers. And then the answer key changes to update. I have examples of missing problems, the kinds of things I will ask you that aren't there yet. And I might be a little more creative, but probably not much. So this is sort of the number of problems you'll have. And I'll change things a bit because some of these are still phrased in the Math 25 way. But this is a good idea of like how much work you will have to do in finals week, if that helps you plan your finals week. Because some of you have lots of classes and need to arrange things with your employer as soon as possible and things like that. Mostly I put this up to help share a heads up of what the rules will be for the final. So calculators are allowed and your own notes are allowed. So one of your jobs this whole term is to make nice, efficient, useful notes. If you try and start finals week doing this final and you'd have just a 3-ring binder of everything from the term, you're going to spend all your time flipping pages and not actually getting stuff done. So have good, efficient, organized notes. And I can help share that. If someone has great notes and wants to send a PDF that I'll put as a reference in a certain week, then I can do that. You are not supposed to look at the textbook, the class website, or other websites. You can take stuff from those sources and put them in your notes, but don't just be like randomly clicking saying, oh, I forgot where this is, something like that. And sadly, working with other people is not allowed. I wish I could say that you could, because as I mentioned before last week, no one will ever say You know, Julie, the company is in danger. Go into this room by yourself and solve this problem in an hour. Right? Math in real life is cooperative, but finals have to be by yourself. There isn't a time limit, so you'll have this thing to work on. And all that will happen, since it's random, is I will print out a different version for everybody. You will each get your own copy of this, so I don't have to worry about people looking at each other's papers. And then send me pictures of your scratch work to turn it in. But then I say, but trust me, 1 or 2 long sessions works better than many tiny ones. So if we have roughly 30, 35 problems, if you try and do 4 problems at a time, 8 times, then you're not going to get on a roll. You won't ever be in the zone or have flow. So set aside a few times this week, finals week, where you have a nice block of time to devote to this. You have to show me step-by-step answers and turn in photos. And then there'll be a second part, which is the oral exam. So now I'll pick on Ashley. So Ashley has sent me her final. I've graded all the work. I've made comments with my pen and sent it back to her. And then we will meet and I will say, you got number 4 correct. Can you explain what you did? Or you missed number 7. Can you find your error? And I might show her someone else's work. Here is some work on the whiteboard from some other student doing number 8, and they messed up. Can you find their error? Or something like that. And this does 2 things. One, it makes sure that you're all actually knowing the work you're saying. I don't have to worry about that your best friend filled this out for you. And 2, that everyone makes careless mistakes. If we look at these 30 to 35 problems that wind up on the test, there's so many little steps in those problems. Everyone is going to make careless mistakes and miss some things. So giving you a chance in an oral exam to fix your careless mistakes lets you end the class feeling that you're on top of things. Because again, in real life, usually your mistakes get noticed by somebody else. I will give you a few freebie problems. So maybe there'll be 35 and I'm grading 32 of them or something like that. And you could either skip 3 or do the others. And that way, if you miss something, I'll just grade the best 32 of your 35. So something like that. So that's the rules for the final. So now you know, and you can talk to your spouses and employers and roommates and kids and so on and get the babysitting and figure out how to plan your finals week a little better. The oral exam will be pretty short. The ones I've done in the past 2 terms remotely have been 5 or 10 minutes per person. So any questions about that? So you can get life ready.
Is finals week gonna be on a Monday or Wednesday?
Finals week is week 11, and I'll send these out on the Monday. And you'll have the whole week to get things done. But getting things done includes me grading it and doing the oral exam. So if you turn something in Friday at lunch, then you better have Friday afternoon available to meet for 10 minutes. So.
And is the oral exam going to be based off of like first come, first serve, pretty much whoever like turns in their written part of it to you,
Yep.
You'll get back to them for the oral?
Yes, if you are like the Roadrunner and finish this by Monday night, then we could meet Monday night or Tuesday morning if you really want to be done and stop thinking about Math 105. All good questions. Anything else?
Where is it located again? Find the practice.
Where do I get to that? Right under all the fold downs is practice finals.
Okay, thank you.
So I need to finish your homework for week 2. That's my priority. But after that, I'm going to work on this and see if I can get things ready. Speaking of that, week 2, I have the homework A ready, but not the homework B. So you can start homework after class. But I've been busy with other stuff too. And again, just a reminder, people have started on the forum for week 2, but you wouldn't know it because you don't get emails for this. You have to go to a little gear and subscribe to things if you wanted to actually get bugged whenever people wrote things.
I looked at the discussion forum and I actually have mine. I just put it into Word and saved it because I saw that you and another person put a picture up with it. I tried to use my snippet to put my picture up, and for some reason I
Julie's
couldn't
asking
get
something about her.
for the discussion forum.
Can you, for the, I'm sorry, you're cutting out. Ask me again.
I'm sorry. So I was looking at the discussion forum for week 2, and I noticed you and another student had put pictures in your discussion that you put up. And I'm just wanting knowing.
You don't need your picture there.
Okay, because I was having issues getting mine to upload.
Yeah, no, it's not important. Okay, any other, just sort of the flow of things, what you're expected to do? Are you feeling ready to start week 2? I want to go over, here's the homework part A, by the way. Somebody had a question last week and it's now your short answer question. Why can't you use the 1+ trick in the simple interest formula? We'll talk about that perhaps. I'll stick it over here for now. Okay, for our Jamboard, here is me writing the.
You're not sharing.
I'm not sharing. Dopey me. Okay, so the first page is just me writing what's at the bottom of your short answer question for 2A. Don't worry about that. There were 2 homework fixes. So I've highlighted in yellow, there was one number that was wrong. I fixed that. And then it was vague in number 8. Is this simple interest or not? So I made a note that it's not. Other announcements. These are my reminders. I've told you the homework's ready. I've talked about the practice final. Due date firmness. So before class started, then I sent out an email saying, how much do you want firm due dates and how much do you want to be able to fall behind and catch up? And everybody that responded said, I like firm due dates. But now we're at the end of week 1 and there are a few people that have 1 of the 2 homeworks done or even 0 of the 2 homeworks done. Should we have people that have started homeworks but are at less than 8 out of 10 able to keep going? Should I just say no more week 1 codes? What seems right to everyone as a class?
Considering that, here, I'll turn my video on. Considering that I'm one of those people that struggled with my homework and my part B is still outstanding, I would love it if you would have more flexibility to the end of today and then after today, then we can be more firm, if that's all right. My week 1 was just really intense for me. So while I like deadlines, it is kind of nice to have flexibility. I need it.
Okay. There is some sense in saying that the due date shouldn't be Sunday at midnight, but it should be Monday at midnight, because then you get the study session on Monday to get your last questions answered.
I like that a lot, having the Monday night instead of Sunday night, just so then you make sure that you are understanding everything before we move on.
Okay,
That
so
sounds
I'm gonna
reasonable.
make a note to myself.
I agree, because I didn't know what questions to ask in the study session today, because like you said, homework was due.
I think
Okay.
also just like what my experience was that I did the quizzes, like I emailed you about this, where like I did the quizzes and then my school email is so flooded with all the forum stuff from like all my different classes. I didn't even see your response that you had graded it already, and I freaked out and thought that I had missed it. So I think having that little extra wiggle room just in case you miss it or like it just skips your mind is good.
Okay. My only complaint about the first week is homework cooperation. I know that at least some of you did homework with each other, which is great. You learn more talking about it with other people. That's why we have the study sessions. But even the people that worked with other people on homework sent me their own codes. It is perfectly legal and encouraged to just sit down and send me a code saying these separate codes if you did work together. If you need help getting somebody to do work with, let me know. And you can even type in the Zoom chat right now. I haven't shared my name and whether I like phone or email for classmates to contact me, but I want people to work with me. So put me in the after class email as somebody that's looking for homework partners. So more cooperation on the homeworks. Subscribing I talked about, tutoring I asked about, Elaine's notes I did.
I do have a question about the drop down where it shows us, gives us a breakdown of our accomplishments. So with the homework, when we have both part A and part B done, it should show 2 homework. Is that correct? Or would it
Correct.
just show? Okay. So on mine, I know it only shows 1 and I did complete A and B. So I wasn't sure about that.
Okay, then there's enough going on with my grading. I do sometimes make mistakes. So either send me an email or send something privately to me in chat now, or even to everyone, just say, check my codename grading. I've turned in both homeworks.
Okay, thanks.
Okay, next slide. We had a study session before class. We did one of the problems from homework 1B. Somebody had a
I
question.
didn't
on
get any
that.
of the achievements for that, our study session that we did.
Okay, they'll nag me. So
I literally just pulled it up so I can see.
one thing I should clarify is that there are achievements for weekly activity, and by that I mean not the homework, but the activity. So if we have time at the end of class, I will say, if anyone wants to do a problem from week 1 or 2 weekly activity, let me know. But we haven't yet. Okay, anyway, today we're going to talk about personal finance more. My internet is slow right now, so I'm sorry about that. In fact, I'm going to go pause and make sure my little one isn't playing some terrible computer game that's sucking all my bandwidth. So I will be right. No, okay, no, he's not his fault. I will just deal with slower bandwidth. Okay, we ended up last time talking about simple interest and how simple interest involves a loan with only one payout at the end. We did all these. The traditional simple interest formula has 2 ways to write it. What you are doing is multiplying 3 things together. The amount of the loan, the principal, the interest rate is always annual, and then how many years go by. And we had some examples where if the time unit isn't years, then we have to put some fraction here. If it was 6 months, we would go 6 over 12 to show it 6 months out of 12 or something like that. A potential problem is that this formula is often abbreviated in a awkward way. By using R, it's not reminding you that this is an annual interest rate. And by using T for time, it's not reminding you that this has to be a whole number of years or a decimal number of years or a fraction number. So put into your brain that this T maybe should be a Y for years, but no one will ever say that. Every book and website you go to will say P times R times T. We just have history to blame for that. So let's do a problem. In our review problem, I'm looking for the interest. The principal is the 3,500. The annual interest rate is 0.045. I'm taking my 4.5%, and I want to change it to a decimal, so I'm scooting it to the left twice. Our little acronym that I'm going to stop mentioning, but some of you love it, is the right into percent, left out of percent. We're going left out of percent. And then we get 0.045. And then the time, the years, well, 9 months, I'm going to write 9 over 12. If you don't like fractions, that's fine. You can write it as 9 divided by 12. Fraction bars and division are the same thing. And once I've set it up, then all the rest is easy. My calculator does the work. So 3,500 times 0.045 times 9 divided by 12. I get $118.13. So questions about that? We're about to start moving forward, building off this. So if you have any questions on this one, ask me so you don't fall behind. No questions. Okay. Am I too close to the bottom of the screen for somebody? There was at least one person last week that couldn't see things at the very bottom. No hollers. Okay, onward. So what happens if we have an apartment, the rent starts at 500, and every year the landlord raises the rent 5%. So my first question is, where did we get this 25 from?
It's 5% of 500.
Okay, we're ready to keep going. What do I write as the starting amount for the second year?
525.
525. Whatever we ended up with before is what we start with the next time. So now I take that 0.05 and I multiply it by a slightly bigger number. And I have to figure out what that is. 2625. So I'm going to add those together and I'll get 551.25. So far, so good. Okay, week 3 or year 3, we're starting at 551.25. I'm going to multiply that by 0.05. And I get 2756. And I add that to the 551.25, and I get 578.81. And so on. Questions about this process? Okay, we could keep going, but you are already bored. So I'm just going to go over here. And there's the numbers. Okay, everything we have so far. You could fill in the table. We could ask questions knowing that it ends at 670.05. Get off. Such as, what's the rent at the end of the 6th year? We could say, why does the amount of increase keep changing? How come these numbers aren't the same?
Because it's 5% of the starting amount per year.
Wait, don't you start
Cut out for me.
the amount, if I'm answering the question, the amount keeps increasing because you start with a higher number each time? I'm not sure if I heard the question all the way.
You're muted, David.
Sorry, my Zoom died. I'm not used to that. Okay, yeah, so these numbers get bigger because 5% of bigger things is bigger. 5% of Bill Gates' income is more than 5% of my income. What's the overall percent change? That's a good one. So we knew that percent change is change divided by original. We did that last week. The change was from 500 to 670.05, so 170.05. Divide it by the 500. And I get about 34%.
So I was writing something when you explained it, but where did you get the 170.05?
I'm subtracting.
So it didn't get filled in on the chart, but the amount for year 6 was 670.05. Oh, there it is. It is on the chart. So it's the difference between 670.05
Yeah, I
and
see
500.
Oh, I see. I see. Thank you so much.
Okay, so overall it changed by 34%. Now, if we have 5% change each year, 6 times, that's 30% changing. Where did the extra 4% come from? How could we possibly get 34 instead of 30 by doing 6 times 5?
It's the same thing as the last question because the number keeps going up each time. It's not the same thing. It's not as simple as 34% of 500. The
Right.
numbers keep increasing each year.
Okay, we did way too much work. Everyone happy with what's on the board so far?
So the percent change equals change divided by the original.
Mhm.
So that, yeah, I'm missing this 170. You got the 670 total and the 170 was the increase.
Right, it's how much it actually changed. It's not new divided by original, it's the change divided by original.
Okay, yeah, change divided by the original. So then what's this minus? Because I guess
The
I missed
yellow
that.
at the bottom is me getting the change by subtracting. New minus original is the change.
Scroll down a little bit.
I can't scroll. It's all, if you need to grab your Zoom control thing and drag it to the top of the screen, that might help if you're on a computer, not a tablet. Sometimes I just have to squeeze. I'm sorry. Okay, this was way too much writing. So let's talk about the 1+ trick. We've seen the 1+ trick in other situations. I could say that 500, rather than first multiplying it by 0.05 and then adding those together, I could use the 1+ trick and just say times 1.05. And I would get to that same 525 quicker. And then I could say 525 times 1.05, and I will get to the same 551.25 a little quicker. And I could say 551.25 times 1.05, and I'll get to the same 578.81 quicker, all the way down the chart. Until we got to finally the 670.05 at the end. So that's less writing. I can be lazier and do that. If you don't remember the 1+ trick or you weren't here last week, the 1 represents 100%. So what we're saying is we have 100% of the 500, and we also have 5% of the 500. And so we get the total in one step, rather than having to add like we did last time. Any questions about this slide before we keep going? Okay, we're still doing too much work. Advanced math is all about being lazy. These numbers that we're finding here in the chart, we don't care about those. We only want to know what happens at the end. These are just filler. So I'm going to make a new one. I have 500. I multiply it by 1.05 and I got to 525. But the fact it's 525, I don't care about. I could just as easily say this 525 is 500 times 1.05. So that's what I will write in the beginning of year 2 instead of 525, because they are the same. There's an equal sign saying that this is the same as that. So if I wanted to write this to begin year 2, I could write the 500 times 1.05, just the same. Then year 2 becomes a 500 times a 1.05 times another 1.05. So the efficient way to write that is 500 times 1.05 squared, meaning multiply it by itself. Then I can keep playing that game. At the end of year 2, I have 500 times 1.05 squared. So I will write that as how I start year 3. And then year 3, I have that times another 1.05. So how do I write that? What's 500 times 1.05 3 times? 1.05 cubed. And then I'm going to take this and put that as the beginning of year 4. And I keep going with this game. And I'm going to just stop talking now because you're bored. But
So what can we call this trick? Just like the other one is the +1 trick.
this one you'll actually not call a trick. So one moment, we're almost ready. And what we really cared about was that this was what, 670.05. So this is still too much work. I am still more lazy than this. We know how this pattern goes. We just did this on the whiteboard.
I got a question.
Sure.
So our forum post for this week, how the hell did you guys post the picture?
Screenshot. I use Nimbus, and it's like attached in my toolbar, and I just take a screenshot and paste it.
What is Nimbus? The only thing I know Nimbus.
Okay, let's stay on this. I don't want to go a tangent yet. So after class, David.
Well, it has to do with this. That's why I was trying to figure out, like, through the example we're talking about compound interest rates. So
Yeah, well, not yet. I haven't used the phrase compound interest yet. So let the people who haven't seen it before get introduced properly.
Okay.
Okay, so we have this formula and we can see the pattern that at the end of year 1, the exponent was 1. At the end of year 2, the exponent is 2. At the end of year 3, the exponent is 3. And my chart happens to have 5 years, but it doesn't have to be that this is 5. Whatever number that is, I could have the formula that y equals 500 times 1.05 raised to that n as my exponent. Whether it's year 6 or year 100, whatever, that's my exponent. That's just how the pattern goes. Everyone okay with that?
Makes sense.
Okay, so this pattern doesn't always have to care about 500. We used 500, but this could be any number. It's whatever the starting amount is, and it just shows up there in the formula. And the 5%, we always used 5%, but it could be any annual interest rate, right? So what we have just invented ourselves is compound interest. The English word compound can mean two different things. It could mean multiple and different parts, like a medicine that's a compound of ingredients, or when something is made greater for some reason, like strong winds compounding the difficulty of putting out a forest fire. And this is both. There's parts and everything gets bigger. So compound interest, the payouts don't stay the same. When we did simple interest, they did. There was one payout at the end based on an annual amount that was just copied. But compound interest is changing amounts. When a problem is simple or compound interest is not a math decision. That's what the bank decides. That's what the treasury bond decides forever, right? The real life situation says this is simple or this is compound. We don't have to figure it out. They tell us. If you want a picture, this colorful picture says that we start with this blue amount. The first year, the blue amount earns interest, so it gets bigger. Now it's thicker by green. The second year, not only does the first amount earn its interest again, we get a copy of the green, but the green earns interest and we get some purple interest also. And then the third time there's a payment, we get another green amount from the blue. Both of these greens will make purples, and the new purple for the first time will have its own interest, so we get orange and so on. So that's a picture representing how the numbers we looked at were getting bigger and bigger each time. You can see a nice spreadsheet going for more rows than we did already, if you wanted to. But mostly I just want to finally give you the formula. And this isn't some magic formula that is hard to understand. We just invented this ourselves. The final amount is whatever the principal was. In our case, it was 500. And we multiply it by 1 plus the interest rate. We did a 1 plus 0.05. And then the exponent is how many rows were in your table, how many times a change happened. I don't really need that purple comment, do I? I know it's not wrapped because I'm pasting it. Oh, okay. So let's do an example of that. A loan has a 3% annual interest rate and it's compounded monthly. So imagine in our brains a table just like we had, but now it's different. Instead of years, each row is a month. Month 1, month 2, month 3, and so on. So stop thinking years and think months for the table. The interest rate, however, is a 3% annual interest rate. So our first step is we have to share the interest among the months. So I'm going to take my 0.03 and divide it by 12, and whatever that is, 0.0025. Then I look at, whoops, the time frame, and I say, I am happy. This is already months. If I wanted to, I could make a table. I don't want to. I could say month 1, we start with 100, we multiply it by 0.0025, so we get 25 cents. And then we add them together and we get $100.25. And month 2, and so on, and make a table like we did before. But that's too much work. Instead, I'm going to use the formula. So final amount is our principal, the 100, times the 1.0025 exponent 18. And whatever that is, let's see. $104.60 after rounding. So I want to talk about this a lot since it's our first time we have compound interest on the board. But before, I want everyone to make sure you can get $104.60 with your calculator. If you're not sure about exponents, so on, let me know.
I did have one question with how you got 0.002.
I had the same question actually.
Yeah.
Because you add the one plus interest rate per payout. So you added the 1 to the
How do you get
0.0025.
the
1 plus trick.
Are you wondering just where this part of the decimal came from?
Yeah, that whole.
No, I'm wondering about how you, where'd you get the 12 from? Like dividing 0.03 by.
Ah, okay, because a year always has 12 months. So this magic phrase, compounded monthly, I don't get to pick that. The problem just says that the bank decides the rules. And they are saying that this table isn't a yearly table anymore. It is a monthly table. So I have to share the 3% among the 12 months, like dealing out cards to 12 different people.
Okay.
So I'm taking 0.03 and I'm doing a divided by 12 to share it among the 12 months. This is great news. Otherwise, your credit card would charge you your full annual interest every month and we would all go broke really quick.
David, I'm sorry, excuse me. I just had a quick question because maybe I'm doing it wrong on my calculator. I'm doing 100 times 1.0025, and then I'm putting the exponent of 18. And for some reason, the calculator is giving me 1.0025 times 10 to the 20th. I'm doing something wrong.
Did you type the key that says EXP on it?
I did.
Yep, that's a bad key.
Oh, okay.
So your exponent key looks like, I need a new color. It looks either like Y to the X, or it looks like this symbol that has the name of carat, like 24 karat gold.
I have
and if
the
you
white.
notice, even if your calculator is more modern and has this on the key, on the screen, all the calculators will use carat for exponent.
Okay. Thank you.
But don't type your EXP key. That's not exponent. So again, holler in the chat. If you're not getting $104.60, let me know so we can diagnose your calculator problems, because you can't do the homework if your calculator is not happy.
So I was going back to the 1.0025. One, is that one from the trick?
Yeah, it's the same reason there's a 1 on the chart right here.
Yeah.
Same reason there's a 1 on the chart right here.
Okay.
That's where it came from. So when somebody asked, is there a name for the trick we just did in the chart? It is. It's called the compound interest formula. But a formula is better than a trick. So, okay, I'm going to talk a lot. First of all, you never have to worry about how much to round. We'll do dollars and cents. Second, the hard part of the formula is knowing what goes in here and what goes in here. We'll do lots of examples, but I had some yellow and some green to get myself ready before plugging things in. And we're going to keep doing that. We're going to get even a little more structured on the page to help you with that. The actual plugging things in and making the calculator do it, that's the easy part. I will also say that simple interest spits out only the interest. If you needed to know sorry, loud phone noise. If you want to know how much is the total amount to pay back in a simple interest formula, you have to add it back on. I would have to add this $118.13 to my initial loan. The compound interest formula is the other way around. It spits out the final amount. So if I was only asked how much interest happened, I would have to subtract and say $4.60 because 100 of it was the principal. So we have to pay attention a lot. We have to say, what's the amount of compounding? What's the time frame? In our table, are these month rows or year rows or whatever? And we have to say, what are they asking? Do they want the total or do they just want the interest? Because if they just want the interest, I have some subtracting to do at the end. Okay, any other questions before we just do some examples? No? Okay, then I will do some examples. So we're doing the same problem as before, except now instead of asking for the total, it's asking just for the interest. I'm going to pretend we didn't just do it and talk about writing things a little better. So I will take my formula. Actually, I'm going to make this even smaller. One moment. Okay. And if I'm you, I'm going to write it on the page. After you do a few problems, then you'll skip that, of course. And then I'm going to list everything out. So I will say final amount. Principal. Rate per payout. And number of payouts. Because again, this is where it's potentially tricky. The problem could be asking us, what's the final amount? It could be asking us, what's the principal? I want to have $2,000 in a few years. How much do I need to start saving now? It could be asking us what the rate is, or it could be asking how many payouts go by before I get the amount I want. So let's just keep track of which of these we know. In this case, we know the final amount. Whoops, no, we don't. I'm distracted by chat. The final amount is what we're solving for.
I actually have a quick
The
question.
principal we know. Sure.
So if we follow this equation that we're doing, right, and we apply it to real life, and we say like our savings account, for example, and we look at, say, after a month, you know, how they normally update and stuff, it shows like 0.01, so 1 cent for however much money you have in your savings account each month. So you're multiplying it by the year, right? So how would you? Well, that's what confuses me on this.
Okay, one moment. Okay. Let me finish filling this out. That might answer your question.
Okay.
So just like here with the division we did, we have a 3% rate, but we have to share it. We don't get the whole 0.03 each time. And the number of payouts, and I'm going to actually label it per month. And the number of payouts is 18 months. I'm not quite sure what you're asking, David, so tell me if this isn't right. At the bank, you would get something that looks more like a table, because every month you will get something in the mail or the email and see what your new balance is, right? So what we're trying to do is skip to the end, use the formula to skip all of that and just say at the end, what do you have?
Okay.
Okay, now I pause and I check that this problem has compounded monthly. Whoops, I keep forgetting to make a highlighter. So do I have months in everything that's a time frame? Yes, so I'm good to go. I can't plug things in unless I've made the rate and the number of payouts measured in months. But the blue part now is the tricky part. Now I can just plug things in. And like before, I don't need those parentheses. And I get the same thing I did before, the 104.60. And then I will finally say the interest, I have to take away the loan. So I've tricked you into watching me do the same problem twice. Okay, the goal of the last few minutes is this format to help you not be confused. What I wrote on the previous slide doing the same problem was not as clear what's happening. I'm trying to be very clear that I want to plug things in this formula. I have 4 different things. So I'm going to keep track of each of them. And then when I plug things in, it works well. Should we do one that gets trickier? Because this is boring.
I did have one question before we move on. Why did you subtract the 100 from $104.60?
Oh, because it asked only for the interest amount. So this is the total. If it's not the loan, everything else has to be interest.
Thank you.
You're welcome. Good question. So I'm going to just do this again and again. And we'll see all the ways this can be tricky. I'm going to stop rewriting my problem by hand. Again, I encourage you to do that the first few times to help you learn the formula. You are allowed your notes on all the tests like we talked about before. You don't have to memorize these, but they should be like familiar, happy things. So I'm going to start with my blue words. So I'm not sure what the final amount is. She has 2,000 to start with. What kind of compound interest is this? Is it monthly? Is it yearly?
Yearly.
It's yearly. It doesn't say. So if it doesn't say, it's yearly. Oh, I'm sorry. I'm doing the wrong problem. I have a simple interest one here. Let me just change the words. I'm trying to do a compound interest formula, but not reading it carefully. Okay, back to what I was saying. So if it doesn't say compounded monthly or quarterly or weekly or whatever, then we're just doing annually. So that means I can be lazy. The 9% is just 0.09. I don't have to fidget with it. It's per year already. And how much does she have after 30 years? It's already in years. Great. Nothing tricky happened. Now I'll plug it in. Final amount is 2,000 times the 1.09 exponent 30, and then I get some answer. $26,535.36.
So is the moral of the story to not borrow $2,000 for 30 years? Whew, it's a lot.
Yes, that's certainly one moral of the story is don't borrow large amounts or any amounts of money for very long times. And that's actually not true because mortgages are great, but we'll get to that much later in the class. Okay, other questions about this one? Okay, let's do the same thing, but now it says compounded monthly. So that means where there's time frames, I will have to make them months. So final amount is still what I'm solving for in this case. The interest rate of 0.09, now I have to share it. I have to say, it's like dealing out cards to my friends. Each of those 12 months gets a share of the interest. So what is 0.09 divided by 12? 0.0075. And the payouts, we have 30 years. That's not months. How do I get that into months?
Multiply by 12.
Yeah. That's the work, right? The setup is the work. Now, when I plug it in, that's not bad at all. Okay, this is a little bigger. It was 26,000 last time, and now it's 29. Why is it bigger? It's still 9% for 30 years.
Aren't you paying like monthly? Isn't it like the different monthly? And
Yeah.
like, I couldn't tell what the other one was. I would have to see the other one. It says monthly and.
This one is just annually. It was per year.
But yeah.
So every month we get a little bit of interest in the second problem. So that builds up on itself faster. It compounds faster. Okay. Can you do more of these as homework? You can copy what we're doing.
Yeah, might struggle a little bit, but yeah.
Yeah.
I see nods. Okay. Some people don't like this. And what they do instead is they memorize different formulas. Oh, I have to shrink it so they don't wrap. One moment. So if you want, in your notes, you can write down, I'll even put this in the whiteboard because why not? You could just have lots of different compound interest formulas that tell you If it's annual compounding, you don't have to fidget. If it's monthly, there's a divided by 12 and a times 12. If it's quarterly, we would divide the years by 4, or if it's weekly, use 52. But these are slightly dangerous because we saw one example where the time frame was already given in months, so I didn't have to do a times 12 here. The goal is to make it match the compounding time frame. If it already matches, we're done.
Do you save these Jamboards?
Yep. The Jamboards are all saved. Let me just show you again. So these orange and black symbols.
Thank you.
Jamboards for past weeks. We'll have one under the week 2 to-do box when we're done. So if you like this, that's great, but just be warned that you don't always do a times 12 unless they give it to you in years. If they give it in months, it's already done for you, and so on. So heads up, you have to be attentive.
And then the formula that we just went over, that's like the universal one where we decide like if we have to read the question, whether it's monthly or years, and then do what we just did, right? Okay.
Right. Most people like this.
Okay.
It's easier to have a universal formula than to try and pick and figure out which formula applies and if it's a special case or not, and so on. But you get to pick. Okay. Annual effective interest is a little side note. It is saying, let's do exactly what we did. And I'm going to put the word rate because otherwise you're going to wonder where is the R from in AEIR. This looks pretty familiar. It's just a little different. So what are we doing? We're saying, imagine you invest $1 and you put the compound interest formula with $1 for the principal. I don't really need that. A times 1 doesn't change anything. And I could see what my $1 grows to be. And then if you're wondering what the interest is, I have to subtract away my original $1 when I'm done. So that's called the annual effective interest rate formula. We have a $1 times our increase, and at the end of the time, we subtract away the $1, so we have only the interest. So if somebody says, my credit card says it's an 18% annual interest rate, but it's compounded monthly, what does that really feel like in my pocketbook? Then I will take my $1. I'll even write it in if you want. And I'm going to multiply it by, we need to figure out the 18 shared among the 12 months. So 0.015. And there'll be 12 months in our 1 year. And then we take away the $1 when we're done. And what do we get? 0.1956. I'm rounding slightly, but who cares? So we saw in the other examples that if you compound monthly, it builds up a little bit faster than if you only build up once a year. So what does it actually feel like in your pocketbook? An 18% per year with monthly compounding feels like 19.56 because of the way it's more than 18 with how it builds on itself. So that's what this formula deals with. It's not commonly used. No one really cares. You just know that an 18% rate is a worse credit card than a 16% rate. But if you care about the details, then here's this formula. That might also be what David was asking me when he had that question before. Does this answer your question better than before?
Yes, it does. It's just, I was trying to implement it into like a real life thing. So I'll look at my savings account, right? And it gives you the percentage for an annual thing. But like when you check your bank account, it shows like only like 1 cent was accumulated for say 20 bucks in your savings account every month. So I was trying to see like why it would only say it was like 1 cent compared to like what annually was, because I feel like you should get more if you're saving. But maybe
savings accounts have such a small interest rate that by the time you divide by 12, there's nothing happening each month.
Yeah.
So one detail, if you don't like this, don't worry too much about it. Okay, next bit of interesting stuff. The rule of 72 says if we want a quick and easy estimate on how long it takes to double, there's a guideline for that. This is great at parties and so on. This is your compound interest party trick. There's a pattern. Imagine that you have $1,000 in an account. It earns 10% interest each year, compounded annually. How many years would it take to double your money? Well, we could do that. If I looked at all the answers, then I'm just using the formula 8 different times. Sometime between year 7 and year 8, I would have my money doubled, right? Year 7 is a little too small, year 8 is a little too big. What about if I earned 7% a year? How long would it take? So I could do all the math and I would see that year 10 is a little too small and year 11 is a little too big. This is just the compound interest formula, 11 different times. I'm showing you rather than making you do it. So a 10% rate took about 7 years. A 7% rate took about 10 years. And it just so happens, and this chart gives you more examples, that if you take the rate, not as a decimal, we're not doing 0.1 or 0.07, we're just pretending it's a whole number. And they multiply it by the years, also as a whole number. When that multiplies to about 72, that means the money is doubling. So at 3%, it would take me 24 years to double because 3 times 24 is 72. At 6%, it only takes me 12 years to double because 6 times 12 is 72. If somehow I could get a 12% interest rate, then every 6 years I would double because 6 times 12 is 72. So if you are getting a savings account in a bank that has 2% a year interest, it's going to take you 36 years to double your money. So good luck on retiring on that. So that's the rule of 72. The annual interest rate times the years until doubling is about 72. It also works if your money is shrinking. If you have $1,000, so this one I just showed you, right? So if you have $1,000 and each year you spend 10%, it tells you how long until it's gone or until it's half. And that's the end of compound interest. The good news is that even though this is a bit complicated, that's as complicated as it gets. Figure out what you have and plug things in. Now I'm lying to you. I can make it more complicated. What can I do worse?
Do it weekly.
Daily?
Daily, I could, but that's just a 365 instead of a 12. That's still, the calculator does most of the work. Okay, what I could do is mess with the money in the middle. So Sir Topham Hatt invests $8,000. He lets it grow for 22 years with 5% annual interest compounded monthly. Great, if we stopped right there, that would be the kind of problem we did. But he's going to try to trick us up. And at the start of the next year, year 23, he moves all the money into a different account for 14 more years with a different interest rate, and now it's compounded quarterly. How annoying. How much does he have at the end? So can everyone see how we have two different compound interest problems? One for 22 years, and then he has some amount that we're going to find, and that will be the initial amount for part B. Everyone ready?
Let's do it.
Let's do it. Okay. Oh, wrong formula. I'm going to keep doing the generic formula because, again, my job is to make the most people happy at a time lecturing. If you are using the time-specific formulas, that's okay too. So part A. The first 22 years. So again, the tricky part is the setup. I'm going to grab my little box. So the final amount is what I'm solving for. We won't change that for a while. He starts with 8,000, good for him. Having that much cash lying around would be nice. Rate per payout, 5%, but things are monthly. So I'm going to write monthly right here. So I'm going to take that 0.05 per year, and I have to share it among the months. I put the little bar over the 6 to show that it keeps repeating. I don't want to round it. I want to put in lots of 6s in my calculator if I'm typing it in again. And then how many payouts? Well, he has 22 years, but each of those years has 12 months. Everyone okay with my blue setup? This again is the hard part. Okay, now I plug things in. I'm going to write this in two different ways. So I'll start out, final amount. Is his principal. Now I'm going to capture my screen. Okay, times 1.0041, and I'm going to put as many sixes as I can in my calculator, right? Exponent 264. And I'm getting $23,978 and some pocket change. Everyone get the same?
Where did the sixes come from?
When I did 0.05 divided by 12, there was a 6 repeating at the end.
Okay, so you put in everything that shows up on your calculator?
I want to type in as many 6s as my calculator will let me, so I'm not rounding in the middle.
Thank you.
Aren't calculators amazing? We just multiplied this horrible decimal by itself 264 times.
Hey, David, is this a good time to get calculator assistance?
Yes, but I want to do one little quick thing first.
Okay.
So you know algebra, unlike a Math 25 student, then some of you don't like that repeating decimal garbage, because who does, right? So what you would rather do, one moment while this registers. Okay. You could say, I'm not going to actually hit that repeating decimal in my calculator all those times. I'm just going to write this as 1 plus 0.05 divided by 12 in the formula. And the 264, on the other hand, is friendly. So a bunch of you right now are saying, yes, that looks a lot nicer than what we had in the previous slide. Make my 2 look like a 2. And that's going to give you the same thing. I'm just taking this part, and instead of putting the answer here, I'm sort of ignoring the fact that I did it in blue up above. Okay, now ask your question, because now I can go back and forth and say which of these you're really asking about, because it could be either. Oh, and you're on mute. I can't hear you.
So this is the kind of calculator that I've got.
Okay.
It's a Sharp ELW535. And when I punch in 8,000 times 0.05 divided by 12, I get a fraction. And in the bottom left, it says N1. So I don't know if you know this calculator, and if you know how I can get out of this mode, and if not,
No, I don't. That's an MRC tutoring thing. They know
Okay.
all the calculators. But
Okay.
thank you for hoping
Yeah.
I am flattered by, but no, I don't.
Okay, no problem.
Okay, we're not done. In any case, whether or not you liked the repeating decimal way to plug things in, or the avoid the repeating decimal way to plug things in, we've only done part A, the first 22 years. So we need to keep going.
First 22 years, okay.
Okay. Do. Oh, come on. Okay, part B. He tried to trick us and mess us up, but we are being slow and careful. And this time it's compounded quarterly. So I'm going to make a note there to myself. So the final amount, that's what we're solving for. What's our principal?
$23,978.46.
Yeah, the answer from part A. Does that make sense to everybody? What's in the account at the beginning of year 23 is what we just found. The rate is an 8.04, but now we have to share it quarterly, and not much that happens in real life has quarterly compound interest. There are lots of stocks that give out dividends quarterly, but that's different. This is a somewhat non-realistic thing. But I'm imagining that 4 times a year, he gets his interest. And let me actually do better. I'm going to keep writing per year here. And it is 14 more years. 4 times a year, he gets a payout. So each of those years has 4 payouts. Okay, everyone okay with my blue? Now I just plug it in. So I'm getting $41,861.84. And that really is as hard as I can make them.
So what is the 1.01 and the 5.6? How did we get that?
The
Right here.
0.01 came from 0.04 divided by 4 for quarterly. The 1 is just part of the formula, that 1 plus trick that we saw in the table we made about rent. And the 56 was we had 14 years, but each of those years, he gets a paycheck 4 times. So we got 56.
Okay. All right, thank you.
So you will be tempted when doing homework to skip this blue stuff and just try to plug things in your head because it's quicker. But write out the blue stuff, at least your first 6 or dozen problems, because that's where all the hard work comes in. Okay.
Clarify, by breaking it into part A and part B, it automatically answers the last question. So you only have to break it into the 2 parts to get that 36 years, correct? As long as we use part A for the principal.
Right, part A was this part of the problem. And part B was this part of the problem. Okay, let's look at your homework. See if I predicted how far we'd get by the end of class or not. So percent change, simple interest, it tells you simple interest. Simple interest, it tells you simple interest. Now we're asking about annual and compound with monthly. 18, oh, that I should change so it actually says compounded monthly. One moment. That's problem 4. Oh, it actually says compound. Okay. Action. I'll put compounded monthly. Okay, now it actually will say in here compounded monthly. It means that each monthly payout will have an interest rate. So this is just the divided by 12 part. And similarly here, we're saying how many periods would you have for 7 years and 6 months if it wasn't years? What about quarters or months or weeks? 6 is the giant problem. Huey, Dewey, and Louie start with 5,000. They have 9%, and they have 13 years. But for one of them, it's weekly. For one of them, it's monthly. And for one of them, it's annually. So how do they compare at the end? That's just like the ones we did here with an annual compared to a monthly. This one is like Mr. Topham Hat. Something happens to the money, then they try and mess us up. They take the answer to part A, they add an extra 10,000. Don't get tripped up. And then part B happens. Here's one single annual effective interest rate problem, just to see if you cared about that.
A question on 7. If it doesn't say that it's compounding monthly or anything, we just assume it's compounding once per year.
Correct.
Okay.
So this one is easier than Topham Hat because it's only once per year. I can even put a note there since you want it. Okay. There you go. Hint, if no time period for payouts is mentioned, it has an annual compound. 9 is your breather. That nice simple problem after some hard ones. And then 10, for no apparent reason, subtract your previous answer from this number. This will be useful later. Then the short answer, we can't use the 1+ trick in simple interest. Here's an example where someone tried and it doesn't work. They get the wrong answer. So can you put into your own words what goes wrong? Ta-da. Okay, we have 9 minutes. I'm going to go back to the main page and first look at last week's activity. Anyone want to get an achievement for doing one of these on the board? If you don't want to now, but want to sort of reserve a spot for Wednesday, then let me know in email or chat and say, I want to do something Wednesday.
Hey, David, I'm sorry, go ahead. Apologize.
No, that's all. Go on.
Board, what do you like on the Jamboree board? Because I don't have a stylus to write on the board.
You could guide me and I will be your scribe, or you could do it on paper and hold it up for us.
Okay, 'cause I wrote all of my activities out, so I could do one.
Okay, pick one.
Let's see. I could do number 5.
Number 5.
Means population.
Okay, so as we did in the study session, give me a moment, computer ready. And then I'm going to focus on you, spotlight, and go full screen. I'm going to stop. Okay, then you share your thing there, and I go full screen and grab it. Come on. View, speaker view. There we go. Got it. Okay. Back to there. And there. And remove the spotlight. Here. It's the wrong shape. Did I get it? No, I did. Okay, tell us what you did, Ashley.
Okay, so it wants to know how much the percentage that increases from 2005 to 2015 of the population. So I took what we had from 2015, the population was 163,000. I subtracted that by 2005's population of 145,000, which gave me a change of 18,000. And then I took 18,000 and divided it by the not the principal, but the first one, 145,000, which gave me 0.1241. And I took the decimal and moved it over to the right 2 times, which gave me an estimated percentage of 12%.
Okay. When I wrote the percent change formula earlier, I used division, but you wrote it as a fraction. And of course, fraction bars and division are the same kind of thing. So great job. We have time for another. Anyone else want to share one of the activities and get that done?
Hey, David, not trying to get the activity done. I just wanted to talk about the homework for this week.
Okay.
I started doing it, and I noticed that every time like I answered number 9, the dot for number 7 would disappear, or vice versa.
That's me. Let me see. 7, 8. Thank you. Okay, I have fixed that. Good, good. I'm glad you noticed. Let me scan the JavaScript real quick, make sure there are no other. Good. Okay, thank you. Good to know. Okay, well, we'll just go 4 minutes early. Let me know if you want to share something activity-wise, and you could always email your written work so I can get it on board ahead of time at the start of class and not have to do the awkward thing where you hold your thing up to the screen like we just did.
I can do one really quick if you want.
Sure,
I can do 7 really quickly.
sure. Let me grab 7 and then get ready to copy it.
And I can do 9 after.
Okay, if people do need to leave at 4, that's fine, but I can stay slightly late. So 7 and 9. Okay, so I'm going to spotlight Eli, stop my sharing. Okay, hold up yours.
Well, I'm going to just explain really quick and then I'll hold it up.
Okay.
So first I'm going to divide the 14, let's see. Yeah, I'm going to divide the 14.49 by 8, and that'll give me a cost per 1 single foot. And then I multiply that by 158.
I got a different answer for that one. And David, you are
Okay, I got it. So there's his. I can double check his calculator stuff. So 14.49 divided by 8. And then times 158. Okay. Yep, that looks right to me. Do you want to hold up yours to see what was different? So, yeah, you did the 158 divided by 8. That's the difference. So he wants a price per foot. So he found a price on the top. The fraction bar is like per and then foot.
okay.
Okay, number 9.
Okay, so here's my thing.
Okay.
I don't know if you can see it.
It's not in focus. Whoops, not in focus yet. I have to stop talking. Can you back it up a little bit? Maybe it will focus. No, webcam quality. Oh, well.
All right, well, I didn't do that much work anyways. It was a pretty simple one for me. But first I was trying to figure out how many pounds was 40 ounces. So I just did 40 ounces divided by 16, and then which was 2.5 pounds. And then I took the $23 and I divided that by 2.5, and I got $9.20 per pound.
9.25. Okay.
No, 9.20.
9.20
per pound.
Okay, looks good. Oh, okay, I'm gonna write names. So this was Ashley, Eli. I forgot to grab your name. Who just did the last one?
Jaden.
Aiden. How do I spell Aiden?
No, Jaden with a J. Jaden.
J. That makes sense. I didn't think I had it. Oops. Okay, thank you, Jaden.
No Y, but yeah.
Okay. What?
There's no Y in my name, but it works.
Ta-da. I will learn eventually. Forgive me. Okay, thank you, everybody. I'm going to stop the recording just in case.